Jurassic Park featured the wrong species for its raptors. Around 115 million years ago in the early Cretaceous period, a Deinonychus, an agile and feathered predator, emerges from dense vegetation. This small theropod, armed with a sickle-like talon on each hind foot, approaches a grazing Tenontosaurus. While the actual pack-hunting behavior of Deinonychus is debated among paleontologists, its formidable weaponry and speed make it a formidable predator in this ancient ecosystem. You think you know this animal. You have seen its modern-day descendants, clever birds that can open doors and use tools. But in prehistory there was Deinonychus, a true master of its world. This feathered raptor stalked the forests of North America during the early Cretaceous period, about 115 to 108 million years ago, using its sharp senses and agility to hunt small prey with remarkable efficiency. Because here's the truth that might break your brain a little: the velociraptors in Jurassic Park. They are not actually velociraptor. The real velociraptor was turkey-sized and feathered, barely reaching up to a human's knee. But if you're looking for a terrifying predator that lived up to its reputation, there's Deinonychus. This raptor, with its sickle claw and sharp teeth, was a formidable hunter in its own right during the early Cretaceous period. Feathers adorned its body, and it likely hunted in packs, preying on dinosaurs much larger than itself. Its real story is far more captivating and scientifically accurate than anything Hollywood could imagine. Welcome back to Extinction Files. Sit down. This one is going to stay with you. Imagine a scene where a pack of Deinonychus, agile and feathered predators from the early Cretaceous period in North America, work together to take down a large herbivore like Tenontosaurus. These raptors were swift hunters that used their keen senses and cooperative strategies to thrive over 115 million years ago. Let us start with the name, because paleontologists do not hand out names like this by accident. Deinonychus means terrible claw, not terrible teeth or jaws. It was the foot that made this predator stand out across deep time. When scientists unearthed Deinonychus from Montana's rocks, they recognized its distinctive feature: a large curved talon on each hindfoot that set it apart as a formidable hunter. On the second toe of each foot sat a curved sickle claw, which was held up off the ground as Deinonychus walked on its third and fourth toes. This adaptation ensured that the killing toe never touched the ground, maintaining its sharpness and effectiveness over time. Ostrom's reconstruction showed this claw to be over 12 centimeters along the curve, sheathed in keratin and hooked like a meat hook, ready for use. This level of specialization indicates millions of years of evolution refining an entire toe into a precise weapon. And here is the scale so you feel it in your gut. Deinonychus was around 3.4 meters long from nose to tail. It weighed something in the range of 60 to 70 kilograms, with some estimates pushing toward 90. That is a grown adult human's weight if you imagine a creature built like a coiled spring. Hollow bird-like bones, a stiffened tail for balance, and a mouth full of backward-curving serrated teeth. But do not picture it towering over you. Its hips came up only to about your own hip level, a little under a meter off the ground. That is the unsettling part. Not a giant looming down, but something low, level, and fast, staring across at you with the eyes of a predator that had been perfecting the ambush for tens of millions of years. Let me tell you about a man named John Ostrom, because without him, your perception of dinosaurs would be vastly different. In 1969, Ostrom described Deinonychus, a bird-like predator from the early Cretaceous period, tilde 115-108 MYA in North America. This discovery revolutionized our understanding of dinosaur behavior and physiology, emphasizing their active nature and close kinship to birds. In the mid-1960s, Ostrom was hunting fossils in southern Montana when his team unearthed the bones of Deinonychus. He formally described this animal in 1969, revealing characteristics that did not align with prevailing scientific views. For 100 years, science had depicted dinosaurs as slow, cold-blooded, and unintelligent creatures, reptilian beasts doomed to extinction by their own evolutionary shortcomings. However, the discovery of Deinonychus challenged this narrative, presenting evidence that at least some dinosaurs were agile, warm-blooded predators, a far cry from the dim-witted lizards depicted in earlier theories. Ostrom studied Deinonychus and recognized it as a highly agile and intelligent predator, far from passive or dull. He saw an animal built for speed. Long legs, that balancing tail stiffened with bony rods so it worked like a counterweight, like a tightrope walker's pole, letting the animal turn hard at a sprint. He saw a killing claw that demanded the animal launch itself at prey with acrobatic violence. This was not a sluggish lizard. This was an athlete Deinonychus, a fast, ferociously alive killer, adapted for swift pursuit and precise attacks on its prey. And Ostrom did something even bigger. He examined the wrist bones, hips, and overall structure of Deinonychus and connected it to an idea that few wanted to accept. Birds are direct descendants of dinosaurs. He argued that this predator and the birds outside your window were close relatives on the same evolutionary tree. That the sparrow on your fence and this 70-kilogram hunter share a common ancestry, making them part of the same family lineage. They laughed at ideas like that once. Not anymore. The concept of pack hunting by Deinonychus is well supported by fossil evidence and computer simulations, showing how these agile raptors work together to take down prey. Birds are indeed living dinosaurs, a discovery made possible largely thanks to John Ostrom's groundbreaking work on Deinonychus and other theropods, which revolutionized our understanding of dinosaur evolution and behavior. This single animal dug out of Montana rock helped ignite what we now call the dinosaur renaissance. An entire revolution in how humanity understands extinct creatures that once roamed Earth. Every fast, feathered, bird-like dinosaur you have seen in documentaries since, every raptor that ever made you flinch, traces back in part to the moment John Ostrom studied Deinonychus and refused to accept outdated theories. Deinonychus did not just live and die, it helped rewrite our understanding of dinosaurs. It emerged from the ground after 115 million years and changed the perception of an entire generation. That alone would make Deinonychus one of the most important dinosaurs ever discovered, providing critical insights into the behavior and evolutionary history of early dromaeosaurid theropods. But we are just beginning to uncover its significance. Because there is so much more to reveal about this remarkable predator. Subject, Deinonychus pack raptor. Let me challenge another misconception. You might imagine this animal as a scaly reptilian creature, but that image is almost certainly incorrect. In reality, Deinonychus was covered in feathers, much like its bird descendants. Deinonychus was very likely feathered. And here is why we are so confident, even though we have never found a Deinonychus with its feathers still attached. We have found definitive proof on its close relatives. On Velociraptor, paleontologists discovered quill knobs, the little bumps on the arm bone where large feathers were anchored. On Microraptor, we have preserved feather impressions in rock. This entire family, the dromaeosaurs, the raptor family to which Deinonychus belongs, was a feathered lineage. Deinonychus sits right at the center of it, surrounded by feathered relatives on every side. To depict it bald and scaly now would require explaining how it alone lost the feathers its entire family possessed. Almost nobody thinks this is possible. And the feathers were not for flight. Deinonychus was far too heavy and its arms too short to achieve powered flight. The feathers served purposes such as display, insulation, and possibly egg brooding. Imagine it now properly. Not a bald reptile, but a massive ground-bound predator with feathered arms held close to the body like folded wings, a long feathered tail, and a face that merges avian features with something primordially terrifying, drawing you in despite its predatory nature. Does that make it less scary? It should not. It should make it worse. Because it means the closest living relatives of Deinonychus are birds, including eagles and hawks. Hold on to that thought. Hold on to it tight. Because we are about to talk about how this animal actually killed, and understanding its avian kin helps reveal the whole terrible truth. For decades, the story was simple and cinematic. Deinonychus used its sickle claw as a slasher, disemboweling prey in one fatal stroke. This idea, originating with Ostrom himself, painted a picture of quick, brutal kills where guts were left on the ground after a gladiator-like confrontation. However, recent studies suggest that the sickle claw was more likely used for grasping and climbing onto large prey rather than disembowelment. Deinonychus, like many other theropods, had feathers and was an agile hunter in packs, making it a formidable predator through coordinated hunting strategies rather than singular attacks. Here is the problem. Someone actually tested it. In 2005, a team led by Phil Manning constructed a mechanical model based on Deinonychus's real anatomy and tested it on a pig carcass using hydraulic rams. The sickle claw turned out to be ill-suited for slashing due to its rounded underside rather than a sharp edge. When they pulled the claw across flesh, it did not slice deeply. Instead, it punctured and gouged shallow holes. This finding challenged the myth of Deinonychus as a disemboweling predator, revealing that its actual predatory behavior likely involved different tactics. So if it didn't slash them open, what was the purpose of that terrible claw? The enlarged sickle-shaped claws on the second toe of Deinonychus were likely used in grasping and holding onto prey, providing a strong grip to help this agile predator subdue its meals. This adaptation allowed Deinonychus to be an efficient hunter, using its speed and agility to catch and keep hold of struggling animals until they could be dispatched or consumed. This is where paleontologist Denver Fowler and his colleagues provided us with a groundbreaking explanation. They proposed the Raptor Prey Restraint (RPR) model, which fundamentally changes our understanding of how Deinonychus hunted. Once you grasp it, you will never look at a hawk in your backyard the same way again. Here is the idea. They studied how modern birds of prey, like hawks and eagles, use their feet when hunting. When a hawk catches prey too large to kill instantly, it does not slash or wait for its victim to die. Instead, it uses its hooked talons to grip and pin the struggling animal down with its full body weight. Then, while the prey is still alive and thrashing, the bird begins feeding. This behavior reflects how Deinonychus, a close relative of modern birds, likely hunted using similar tactics. Now imagine that big sickle claw on Deinonychus. It wasn't a slashing blade but rather a grappling hook, a pinning spike, an anchor to drive into flesh and hold prey in place. This claw was not for opening wounds. It was for preventing the victim from escaping, allowing these agile predators to maintain their grip during hunts. Do you see where this is going? Do you see what that means? Recent discoveries show that Deinonychus, a close relative of Velociraptor, lived in packs and worked together to take down large prey, showcasing their intelligence and social behavior. This collaborative hunting strategy was key to their success in their late Cretaceous ecosystem. It means Deinonychus may not have delivered a clean, merciful death at all. This predator would pounce on its prey, drive its sickle-shaped claws deep into flesh, pin the prey to the ground with its powerful body and weight, and then begin feeding even as the prey was still breathing and struggling. Fowler and his team described a behavior they called stability flapping. Those short feathered arms were used by Deinonychus to maintain balance on top of thrashing prey, allowing it to stay upright and locked in combat while the prey fought for its life, securing its meal mouthful by mouthful. This detail underscores an intriguing evolutionary hypothesis. The motion involved in stability flapping may have laid the groundwork for the wing beat of flight. The flapping stroke seen in modern birds could have originated from theropods like Deinonychus, using their feathered arms to stay balanced on struggling prey. That is not a monster from a movie. A movie monster kills you and it is over. This is a bird of prey the size of a man, holding you down and eating you alive. That is what the fossils and living birds reveal about Deinonychus. Equipped with sharp claws and feathers, this agile predator thrived for millions of years during the early Cretaceous in North America. Let it sit. Let it get uncomfortable. Now let me take on the last thing you thought you knew about dinosaurs. Did you know that Deinonychus, a fierce predator from North America during the early Cretaceous period, tilde 115-108 million years ago, was actually covered in feathers and lived in packs? Far from being solitary hunters, recent studies suggest Deinonychus worked together to take down much larger prey, showcasing remarkable cooperative behavior that would have given them a significant advantage over their contemporaries. The pack. The famous terrifying pack. Deinonychus often depicted working together like wolves, flanking their prey, communicating, and setting ambushes to drive victims into traps. This image is iconic, capturing the intelligence and cooperative hunting strategies of these agile predators. Feathers covering their bodies are evidence of their warm-blooded nature, underscoring their active lifestyle and likely social behavior. What if I told you the evidence for Deinonychus living in packs is a lot shakier than the movies made it look? While there are suggestions of cooperative behavior based on fossil finds, definitive proof of pack hunting remains elusive. Here is where the idea actually came from and why it is so seductive. Remember Tenontosaurus, the large plant eater from the opening scene? Paleontologists keep finding them entangled with Deinonychus remains at various sites. At some locations, a single Tenontosaurus fossil is surrounded by several Deinonychus skeletons and littered with shed Deinonychus teeth, which these animals constantly replaced as they fed. The presence of multiple raptor remains around one large kill site suggests coordinated hunting behavior among Deinonychus. It looks like teamwork. Ostrom himself proposed this idea decades ago, and for years it was considered strong evidence that Deinonychus hunted in packs. This interpretation has since been widely accepted as a key insight into the social behaviors of these remarkable predators. Except it was not closed. Because look at that scene again with cold eyes. Multiple predators feeding on one big carcass does not prove they cooperated to bring it down. It just proves they all showed up to eat. And when you study animals mobbing a carcass in the modern world, the picture can turn ugly fast, with dominant individuals aggressively defending their share from others. In 2007, researchers Brian Roach and Daniel Brinkman drew parallels to another living animal, the Komodo dragon. When multiple Komodo dragons converge on a carcass, it's not a coordinated effort but rather a chaotic free-for-all where larger individuals dominate smaller ones, often driving them away from the food source. Occasionally, if a weaker individual becomes entangled in the melee or is too slow to escape, it may become prey for its competitors. That is the alternative model for Deinonychus. Not a disciplined wolf pack but a snarling mob, a mess of half-cooperating, half-competing killers descending on the same prey, fighting each other as much as they fight the meal. This theory gains weight from findings at some Tenontosaurus sites, where shed and broken Deinonychus teeth are mixed with the herbivore's bones. Researchers argue that this damage may have been inflicted by Deinonychus biting into each other during feeding frenzies, turning on their own and potentially even cannibalizing the dead. Then the chemistry came in and pushed even harder. In 2020, researcher Joseph Frederickson and his colleagues proposed an intriguing idea. If Deinonychus hunted cooperatively like wolves do today, then adults and juveniles would have shared food resources. The chemical signature of diet, locked into growing teeth, should be consistent across all age groups if they were indeed part of cooperative feeding packs. It did not. They analyzed carbon isotopes in Deinonychus teeth of different sizes, from small juveniles to full-grown adults, and found that dietary patterns did not match across age groups. This indicates that younger individuals were eating differently from the larger ones. Such behavior is inconsistent with cooperative pack dynamics like those seen in wolves. Instead, this suggests a more solitary lifestyle where young Deinonychus fended for themselves, kept their distance from potentially dangerous adults, and only joined group feeding events as they matured, resembling behaviors observed in crocodiles or Komodo dragons. While the concept of Deinonychosaurus forming intelligent and coordinated packs remains speculative, evidence suggests that these feathered predators were indeed formidable hunters capable of complex behaviors. Studies indicate that Deinonychus had keen senses and powerful legs, traits suggesting they could work together to take down prey. However, direct proof of pack hunting behavior is still lacking in the fossil record. Now I want to be honest with you, the way real science is honest, because this is a live debate happening right now in the field. There are serious paleontologists who still argue for some form of group hunting, who look at those clustered carcasses and see something more than a random mob. The chemistry studies and comparisons with modern Komodo dragons have pushed hard against strict wolf-style teamwork, but nobody has the final word. That is what makes it so alive. That is what makes it real. We are watching scientists argue in real time over the mind and manners of an animal that has been dead for around 120 million years, reading its behavior out of scattered teeth and chemical traces in fossil enamel. And while the picture emerging does not support the clever, disciplined hunters seen in films, it leans toward a more solitary, territorial hunter, meaner, wilder, and driven by instinct rather than teamwork. So let me reintroduce this animal, reconstructed based on the most recent and robust evidence available. A feathered predator, the size of a grown man low to the ground, fast, closer kin to an eagle than any lizard. Deinonychus likely hunted in loose groups, but not with the precision coordination seen in films, more akin to Komodo dragons interacting at a carcass. Its young may have eaten different food and avoided adults due to cannibalistic tendencies. When it caught prey too large to kill outright, Deinonychus used its sickle claw to pin the animal down, flapped short feathered arms for balance on a thrashing body, and began feeding while the prey was still alive. That is Deinonychus. The real feathered predator, not the exaggerated villain from screenplays. This raptor was a swift, intelligent hunter that lived in packs during the early Cretaceous period, tilde 115-108 million years ago, in what is now North America. And here is the last thing, the thing that should give you chills. This is one of the animals that changed how we see all dinosaurs. When John Ostrom pulled it from the rock, it helped destroy the myth of the slow, stupid, cold-blooded dinosaur, and replace it with something fast, warm-blooded, alive, and terrifying. Every dinosaur you love or fear, you see it the way you do partly because of this animal and this discovery. Deinonychus did not just terrorize the forests of ancient North America. Its discovery rewired our imagination, showing us that dinosaurs were dynamic, intelligent creatures covered in feathers. The terrible claw. It earned every letter of that name. You will never look at a hawk the same way again. Watch it stand on its prey, holding the animal down while it starts to feed, even as the prey struggles. This behavior reflects a small surviving echo of the predatory prowess seen in ancient raptors like Deinonychus. While dinosaurs did not survive entirely, some lineages shrank, grew wings, and took to the skies. The pinning and feeding behavior displayed by hawks is an example of how certain traits from their dinosaurian ancestors persist today. Sleep well. This has been Extinction Files.